I've forgotten to videotape them. So on page 200, chapter 5. All right, if you see there, they're talking about sine of a negative angle is equal to or minus the sine of the angle. And the book will try and show you in terms of going around the rotation. But I think that when you're dealing with sine, although this is not angle, it's, you know, it's a unit circle, and doing the arc and laying out the trig functions for an arc, I think it helps maybe to see what it is. It's called plan ahead with your, and I'm just going to lay out. And the first thing they're talking about is they're trying to talk about this sine of a negative angle is equal to the sine, negative the sine of the angle. And for me, it is quite easy to see when you think about if this is 2 pi and then pi over 2 and 3 pi over 2, negative pi over 2, negative pi, 3 pi over 2 negative, and negative 2 pi. If you think about the sine curve, it goes like, so I'm not trying to be terribly accurate here. You see it, if you, the negative theta would be along this line, right? Notice that if you go in this direction, this is going to be the value of the sine, right, for the distance from here to here. And you can see that it's equal to the opposite of this. It's the same height, but it's negative direction. So when you're going in this direction, if you go in this direction, you have to change the sign of what the height is. And I think it becomes pretty easy to see that this relationship holds. So if you think about it, you know, and you kind of forget what it is, if you think about this sine wave for a sine curve, and then the cosine wave, it's going to go like this. So when you go the cosine of a negative angle, if you go this way and you go this way the same distance, they're going to be equal, right? For the sine curve, you have to, here it's negative and here it's positive. So you have to do a negative, a positive. And I think once you look at it in the sinusoidal laid out curve, it's pretty easy. When you look at it circularly, in a circular fashion, it's not as easy to see, but I think this is pretty easy to see. It isn't, these aren't angles, but these are understanding that this is the unit circle. We've converted unit circle, and then distance on the unit circle is the same as the central angle in radians. And then that central angle in radians is equal to the degrees on a unit circle. But I mean, the functions are the same, the value of the sine and the cosine. So those things, you should be able to kind of understand what it's doing and what it's about. Now that tangent, remember that the tangent, and I'll sort of lay it out on the same. Remember the tangent comes down and goes through this way, right? So if you do tangent of a negative, what is it going to be? When you go this way and this way, what are you going to have to do? You'll have to put the minus sign here, right? Same reason that sine of this sine of a negative is equal to negative sine.
The output's the same, it's just
It's opposite. It's
the graph
the
is
opposite
the
sign.
same.
Yeah. What's that?
It's the negative sign that you have up there of the angle.
Mm-hmm.
It's exactly the same for
Yeah.
the negative sign.
Yeah. See, if you go a minus 30 degrees on sine, you're going to be 1/2 down negative. But if you go positive 30 degrees, you're 1/2 up.
But it's not.
So the sine of a negative 30 is the same as a negative sine of 30. That's what you were trying to say?
Yeah, it's the positive sign is the same thing as the negative sign. It doesn't change the graph any.
Yeah. The absolute values of these two are the same. It's just that this one is opposite sine of this direction. And then when you do cosine, because it's symmetric, that green line is symmetric about the y-axis, it's going to be the same value as you go to the right in the same distance to the left. And that's why this doesn't have a negative, and that's why this has a negative, because when you go this way, they're opposite sign. So you can, to me it makes sense. I can logically see it, and then I can do the. And these are identities, and then the fundamental identities down below there we've had them before, where it says cotangent's 1 over tangent, secant's 1 over cosine, cosecant's 1 over sine. Those are all. Tangent is sine over cosine, cotangent is cosine over sine. The Pythagorean identity, if you learn this one, sine squared plus cosine squared equals 1. All those others come from that one. So if you can't remember the other ones and you're out someplace trying to figure it out, that that second one where it says tangent squared equals secant squared, no, equals plus 1 equals secant. What am I doing? All that's just this one, and what you've done is you've taken 1 over cosine. See, so this becomes sine over cosine, tangent squared. This one is cosine squared over cosine squared, which is 1. And this is 1 over this is supposed to be squared. 1 over cosine squared is secant squared. So you're just taking this and dividing it by cosine. And the next one, which is that 1 plus cotangent squared equals cosecant squared. That's just this thing divided by sine squared, right? Sine squared over sine squared is 1. Cosine squared over sine squared is cotangent squared, and 1 over cosine squared is cosecant. So if you basically know this one, you can figure these out. If you don't have a sheet, and I didn't look for it, but the only thing is if we don't have it, I'm going to make a sheet with this whole chapter on it. And then the negative angle identities, we've already talked about that. Sine of a negative angle is equal negative sine of the angle. And because that and the relationship between sine and cosecant, then cosecant has that same relationship. I'm looking at the bottom of that box. Right? So if you know that row across the top, if you know this sine of a negative angle is a negative the sine of the angle, and that should make sense because it's this blue line. When you go this way, you have to switch the sign of it, right? Then what is cosecant? And what is the inverse of sine? It's cosecant. So then cosecant of a negative equals a negative cosecant. Because this is just the inverse of that, right? So then this has to hold for it. And then the cosine of a negative angle is equal to negative, no, plus, is equal to cosine of the angle. And that was just because it's this, as you go this way and this way, the vertical distance is the same direction, right? Positive, when it's positive here, it's positive there. When it's negative here, it's negative over here, when you get the distance away. And then because the relationship secant is the inverse, so then if you go secant of a negative, the angle is equal to the secant of the angle. And then the last one is the tangent. The tangent going negative, what does it got to be? Negative the tangent, right? And because that's so, and the cotangent's 1 over tangent, so then cotangent of a negative has got to be a negative cotangent of the other. So basically you learn this, and you know this. Rest of them fall out from that. And then they're going to get some other identities from this thing, and that's going to be on the top of the next page. They're going to say, since sine squared plus cosine squared equals 1, then you can do cosine squared equals 1 minus sine squared, or you can do sine squared equals 1 minus cosine squared. So if you know this one is, if you know sine and you want to know cosine, then you plug the sine in here, square it, and then take the square root of it. You've got cosine, then all you have to know is what quadrant you're in. And then you can get the right value. Because it's either going to be positive or negative depending upon the quadrant you're in. And then the same way here, once you know cosine, you can get sine by doing square root of this. Okay, so let's look at 203, and we'll go around the room. I'll do the first one. Notice it says tangent of theta equals 2.6. Now they want to know tangent of a negative theta. Because the identity says this, tangent of negative theta equals what? Negative tangent theta. And this has to be what? Negative 2.6. Okay. This.
So does that make number 2 positive 0.65?
No, because what, this is number one. What is the identity for 2? The cosine of negative theta is equal to what? Just cosine of the positive theta. No change in it, right? So if cosine theta, if this one equals negative 0.65, then this one has to be what? This one has to be the same, right? Negative 65. They're the same. You don't change the signs. This tangent, because tangent of negative theta equals negative tangent theta, then you have to change the sign. But cosine of negative theta equals cosine theta, you don't change the sign. They're just whatever the value of cosine is, the cosine of the negative angle is going to be the same. What it is you have gone on this cosine curve out to the point someplace out here, right? Between here and here, so it's negative. Now, if you go that same distance from here back, what are you going to have? The same value. It's going to be negative, right? Does that make sense?
Yeah.
Okay. Okay, number, was that number 3? Yeah. So they're telling you tangent of theta is 1.6, and now they want cotangent theta. So what relationship are you going to use? Cotangent equals what? 1 over tangent. So then you're going to make this as what? Okay, 1 over 1.6. Divide it out, right? Have some sort of a decimal. James, what, number 4? We got cosine theta is 0.8, and then it says sine theta equals 0.6, then tangent of minus theta, I'll give you a hint. This is the same as what?
Oh, sorry. No. I'll take it in.
This is the same as the sine of a negative theta over the cosine of negative theta. Now notice we're given positive thetas. So
would you make both of those negative and then divide that to get that, or
okay,
not?
what's the identity? The sine of theta how is it related to the sine of negative theta?
It's the same sign, so it actually.
This one's opposite sign,
Oh, it is a sign?
right?
Okay, yeah.
But the cosine theta is what? Cosine of negative theta. You don't change the sign, right? So what are we going to put? What are we going to put right here?
So it would be a negative 0.6?
Yep, negative 0.6 over.
Positive 0.8.
That makes sense?
No, yeah, I think I made a typo.
Yeah. See, they're giving you sine and cosine. They're asking you for tangent of a negative, and then we're using the identity that the sine of theta is equal to a negative this. So that means we have to change the sign of this one.
Right, so sine changes, cosine
Doesn't.
doesn't.
Yeah, and if to get it straight in your head, if you see this thing here, when you go this distance out here, it's positive. You go the same distance there, it's negative. That because this is the sine curve, blue, right?
Right.
Then this is the cosine curve. So if you go a distance out here and you go the same distance back here, they're the same sign. Whether they're positive or negative, they're the same.
And
Tangent, when you go this way, this is what it is. When you go this way, it's down here.
Yeah.
So it's a negative. All right, Corey.
We do the same thing with, solving with the sine and cosine positive, and then do the grade with just the tangent.
Are you saying, okay, I'm not sure.
So like, solving it with the sine and cosine and the positive.
Yeah, you could, okay, I see what you're saying. What you're saying is that I'm going to solve for tangent of positive theta. Yeah. And that's going to be sine theta over cosine theta. And that's going to be 0.6 over 0.8. And then the idea is that tangent of positive theta equals a negative tangent theta. So if I do, I have to change the sign over here, right? Do you see what Corey's saying? He's saying go ahead and use the sine theta over cosine theta to get your tangent of positive theta. Then use this idea to change this side. Yeah. But this one would say, if you did it this way, technically what you're doing is you're putting a minus sign out in front. This one you're putting a minus sign in front of the sine, which makes no difference because a minus here is the same as a minus out here is the same as a minus. Just different ways of looking at the same thing. So, Chris, number 5. We're given sine. So it's a negative sine of a negative theta. So this is kind of two things. This is a negative out in front of this thing. And the sine of this is a negative sine of a positive theta, right? Because we're given this. So then what you have to do is you have to put this negative, then we put a negative 2/3 in here, and then that's a positive 2/3. You're doing, see, they're giving you sine at 2/3. Sine theta is 2/3. Well, this sine of a negative theta is a negative that, right? But then they want you to do the opposite of that. So then it comes back to this. You see what it's doing? See that this is what's given. This is what they're asking. So this minus sign comes down, and then what I'm doing is I'm solving this with this information. So the sine of a negative theta is a negative the sine of theta. So then what I have to do is the sine of theta is 2/3. I have to do a negative of it, and then it wants me to change that sign to a positive.
Wouldn't that be the exact same thing as saying that it's 2/3, positive 2/3?
It is positive 2/3. This is the answer. But that's the process that you're going through to figure it out. Okay, number 6. It's given you cosine theta is a negative 1/5. Now it wants a minus the cosine of a negative theta. So this technically has to be in a bracket because it's saying take the cosine of a negative theta and opposite the sine of that. Well, the cosine of a negative theta, dang it, is equal to a cosine of theta, right? Because these don't change. Right?
What happened to theta sine of theta?
Well, they don't change. Then I'll look at what you said. Yeah. Well, this is the relationship. Cosine of a negative theta is equal to cosine theta. Cosine theta is a negative 1/5. So the answer to this is a positive 1/5. What?
That was a negative.
Yeah. But you're using this identity. Because what you're given this, you're not given this. And this is a negative 1/5. That's all I'm saying is you're substituting in what you have for what they asked for. All right. Feet says, now notice it says find sine theta. So what we're given is we're given cotangent theta equals negative 1/3 and theta in quadrant 4. So the sine in quadrant 4 is going to be a negative value, right? The result is negative in the fourth quadrant. That's what this is about. So whatever I get, I have to take the negative of it. Now cotangent, you got to go back and use the relationship where it's saying 1 plus cotangent squared equals cosecant squared. Because we don't have a direct relationship between sine and cosine. So I'm going to use 1 plus cotangent squared equals cosecant squared. Because cosecant's 1 over sine, right? So that's the process I'm going to go through. So I will solve for this and invert it and then take the square root of it. When I take the square roots plus or minus, then I have to take the negative of it, right? You see where I'm going with this?
Sorry, can you say that last part again?
Okay, once I find the sine, see this thing here, in order to, I can find cosecant squared by inserting a negative 1/3 in for cotangent. Then I'm going to invert it, but then I'm going to have to take the square root. And when I take the square root, it's going to be plus or minus the square root, and this tells me I take the negative. So this is what I'm going to do. 1 plus a negative 1/3 squared equals cosecant squared theta. So then this is 1 plus 1/9 equals cosecant squared theta. And this is 9 over 9, right? To get a common denominator. So this is 10/9 equals cosecant squared theta. But that thing is 1 over sine squared. So I can invert this, sine squared theta equals the invert of this. Correct? And now I take the principal square root here, and then it's plus or minus the square root there. So I get sine equals, and because I'm doing the what, fourth quadrant, and the fourth quadrant it's negative, this is plus minus, so I take the negative. Square root of 9 over square root of 10. Now, this is going to be a minus 3 over square root of 10, and I can't leave the square root in the denominator, so I have to go square root 10, square root 10. So then the answer is the sine theta equals a negative 3 square root 10 over 10. And that's the answer. That's you've got to use your identities and try to figure out what it is. No, not all of them are that difficult. If you look at 10, it says they're giving you tangent theta is a negative square root of 7 over 2, and they want secant. Well, they want sine, but secant is greater than 0. Secant is really what? 1 over cosine? Isn't secant 1 over cosine? So that says the cosine is greater than 0. So which quadrants am I in? 1 and 2? So I'm in quadrants 1 and 2. And if tangent's negative, that means sine has to be negative, correct? Yeah.
Maybe quadrants 1 and 4 for
Okay. You're right. 1 and 4. But if the cosine is positive, the tangent's negative, and tangent sine over cosine, it means sine is negative. And sine's what I got to solve for. So sine of my angle is negative. Because secant's positive, 1 over cosine is the identity there. Cosine's positive, that means tangent is sine over cosine, therefore sine is negative. Because this is a negative value. Now I want to solve for sine when I got tangent is equal to this. Well, I can't use the identity sine over cosine because I don't have a value for cosine. So I'm stuck with going back and doing this. This one is gonna, I don't know, no matter how you do this one, it's gonna be tough. I'm gonna have to go back to my way of thinking. I'm gonna have to use this identity. And this is going to give me 1 over cosine squared, right? Then I'm going to have to take the result of cosine squared and put it in 1 cosine squared plus sine squared equals 1, and then get sine squared equals 1 minus cosine squared, square root both sides. To get sine, because they're asking me for what? Sine. And I'm going to have to use, they're giving me tangent. And the relationship I have is tangent squared plus 1 is secant squared. And secant squared is 1 over cosine. So I can find my cosine, and I can use this identity to find my sine. Correct? So that's what I'm going to do. So I'm going to put my value. I got a negative square root of 7 over 2 quantity squared plus 1 equals secant squared theta. Now this is going to be 7 over 4, right? Plus 1 equals secant squared. I have to do a 4 over 4 So I got 11 over 4 equals secant squared theta. But that's 1 over cosine squared. So now what I'm going to do is I'm going to invert this and invert that. So I got cosine squared theta is 4 over 11. And then I'll go up and put that in this equation, but I'll put it in this one. So I have sine squared equals 1 minus cosine squared. Cosine squared is 4 over 11. 4 over 11. Common denominator, this would be 11 over 11. 11 minus 4 is 7, so then I got sine squared equals 7 over 11. Then I take the square root of both sides. This is going to be plus minus, but I said I got to be what? Negative. So my answer is going to be sine of theta is a negative. And I can't leave that square root of 11 in the denominator. So I have to, this is actually what I got. I have to rationalize that denominator. Okay, square root of 11 over square root of 11. So this is going to be a minus 7 times 11, square root of 77 over 11. And this should be my answer. So it requires you doing a whole bunch of using your identities to calculate it out. And, you know, I'm telling you, the only way that you're going to recognize how awful these are is do them yourself and try to figure it. Yeah. But you just got to wrestle with them. But they can be just awful to try to deal with. Now, some of them, like 12, I think 12 is pretty easy. Cosecant theta equals a negative 8 over 5. This one is easy compared to cosecant is what in terms of sine? 1 over sine. So all you do is invert this, and you invert this. I wish every one of them were like that. Okay, 205. We'll do a concept thing. We'll just go around the room. Okay, Chris. This first one's easy. Cosine over sine. Pick the A, B, C, D, E. Which one? What did you say first?
Oh, I said that D.
No. Cosine over sine is, what is D? D, sine over cosine is what? Yeah. Boy, you're narrowing it down because that's wrong. Okay, what, anyone? D, cotangent is cosine over sine. I'm waiting for you to say yes. You understand? You understand, right? Cosine, see, tangent is sine over cosine, right? Cotangent is cosine over sine. They're giving you the cosine over sine and asking you to identify this cotangent. All right, 34. Then, Beth, you get to do it again. Okay, did everyone see? Tangent is sine over cosine. Right, Chris?
Yeah, I think I just need to copy sheet.
Yeah, you need to look at your identities. Okay, 35. James, use that identity. What the cosine of a negative theta is equal to what in terms of theta?
Cosine, x.
Yep. So which one is it?
Oh, sorry, e.
E, right? That's just that identity.
Yeah, we had that.
Yeah.
You wrote it up there.
Yep. 36, Chris.
E.
Okay.
Squared x.
Okay. That's just one of those fundamental identities. 37, Lucas. Okay, sine squared plus cosine squared equals 1. That is your friend. That thing, you can get all those other ones, off of that if you can't figure it out. All right. Corey, 38. Okay, Corey says C. Did you say C? Oh. Well, 38, you see that 38 would be C. Let's just go minus tangent x cosine x. So if you think of this is sine over cosine, right? Times cosine. So one thing it could be is a negative sign, right? And a negative sine of x is equal to what? It's equal to sine of a negative x, right? That's just one of your fundamental identities. I mean, you don't know that you got to play around with it to kind of see that that's what it would be. Okay, 39. Guess who? Chris. One of your fundamental identities. Look back on that box. Page 200. It's just a little bit of manipulation on that one of those fundamental identities. The box on page 200, bottom of the page. Look at the Pythagorean identities and look at the second one, tangent squared plus 1 equals secant squared theta. Can you manipulate that around so that you can get secant squared minus 1? No. Look at that identity. Tangent squared plus 1 equals secant squared. If you subtract 1 from both sides, what do you get? Secant squared minus 1. Now then, what is left on the other side? Tangent squared. Now, any one of those A through F that is equivalent to tangent squared? What is the identity in terms of sine and cosine for tangent? That's cotangent. Okay, and tangent squared then would be what in terms of that?
So sine squared
Over, yep. Do you see that?
Yeah.
Say, I mean, you got to use a bunch of stuff. All right. So you should go through and look at those things, figure them out, because like I say, if you plan on doing anything beyond an AAS degree, you're going to be taking calc because of your science people, and you'll be taking calc 1, 2, 3. Calc 2 is going to use these distinctive things. It's going to use all these identities, double angle, half angle, and everything. And the more I can get through it with you, at least you'll have exposure to it. And I bet in your lifetime you'll go back and do it. Don't you think?
It's possible, but I hope not.
You'll want to advance yourself, and you'll have to get a BS degree. And
Stare at oscilloscopes for 5
Okay. Well, for those of you that do it, it'll hit you. And it's good, it's just good mental thought, critical thinking.
On the spot.
Yeah.